Okay, so you guys, we've been talking about all the trig functions, the sine, cosine, and tangent, and I forgot to give you this little acronym right here, but I've heard several of you guys say it. How many of you know this acronym right here? SOHCAHTOA. How many of you have never heard of it? If I raise a hand. SOHCAHTOA. Okay? When you guys take the ACT test, for example, you'll want to have this memorized, okay? Because it's just saying the sine of an angle is equal to opposite over hypotenuse. In other words, that SOH is this S, this O, and this H, okay? So that helps you remember that, okay? So, and then CA means cosine of the angle equals adjacent over hypotenuse. And TOA means TOA means tangent of theta equals opposite over adjacent. I know when I learned this in high school, I used that acronym, and it helped me to remember when I took like the ACT test and so forth, because you can't have any 3x5 cards in there. So this will help you remember that stuff. Yes, you can use graphing calculators on the ACT test. So if you have your graphing calculator, most of the problems don't require a calculator. They can be done without it, but they're easier if you have one. Okay, everybody's attention up here. Okay, problem number 12 on 6.11. Guys, please listen. Okay, problem number 12 on 6.11 gives you a triangle. It looks like this, and you're supposed to solve the triangle, kind of like the bell work problem. Okay, so we can use the Pythagorean theorem to find the hypotenuse. So that's going to be 4 squared plus 5 squared equals c squared. And so we're going to get 16 plus 25 is 41. And so c is equal to the square root of 41. Now, most textbooks that you ever look at will leave your answer as the root of 41. And that's what I would always suggest. But this booklet always gives the answers as decimals on these. So we're just going to look at this really quickly and see what they do. So this is 6.11, number 12. Is that correct? So what is the square root of 41? Okay, so then they give the answer 6.403. I would like you guys to round these to 3 decimal places when you do them. Okay? So we find that. Remember, that's the same thing as the square root of 41. Okay? Either way on the test, I'll give you credit. So when we take the test, give it either way. Now, we need to find an angle. Well, we know that if you go to angle A right here, which 2 sides do we know from angle A? We know all 3, but this one right here it's an approximation, right? So we want to use one of the 2 exact ones. We know these 2 right here, but what sides are those from A, angle A? Adjacent and opposite. So what relates adjacent and opposite? The tangent. So we're going to go tangent of A equals opposite over adjacent, right? So 5 over 4. Now to solve that for an angle, we take the tangent inverse of both sides. Well, they're going to cancel out on this side, so you're going to get A equals the tangent inverse of 5/4. I made that look like a 15. Tangent inverse of 5/4. Okay? And so we just plug that in the calculator. What do you get for that angle? Round it to 3 decimal. What? 51.34? 340? Okay, and then how do I find angle B? Subtract from 90. So 90 minus 51.34 is what? 30. 38.65. 38.66. So if you're going from minusing 0.34, then it's going to be 0.66. Okay. Any questions on that? Any other questions? Did I answer your question, Alyssa? Okay. Number 4 on which one? Number 4 on 6.11. Okay. Okay, so on this one, we are supposed to, and by the way, this is problem number what again? 4 on 6.11, right? So we're supposed to set up a proportion and solve this. Well, there's a couple of proportions we could write. What's one proportion we could write? Okay, let's do this one. X over 6 equals x minus 2 over 4. Can we do that one? If we cross multiply, we get 4x equals 6x minus 12 if we distribute that 6. Only times it by the x minus 2, right? To solve this equation, I minus 6 from both sides. 6x. I'm going to get negative 2x equals negative 12. So divide by negative 2, and I get x equals 6, right? So we're saying that this right here is 6. 6 minus 2 is 4. We're saying this is 4. Well, Christian brought this up to me. He goes, that doesn't look right. Why doesn't it look right? Yeah, that distance is way different than that distance right there, right? But what I want to tell you is sometimes when they draw diagrams, mathematical diagrams, they don't always draw them to scale. And so this is the correct answer. The only thing is they don't look like it's the right answer because they're not drawn to scale. You got to remember that about drawings. They're not always to scale. Now, if you're given something that's drawn to scale, then you can make that assumption. But on this one, you can't do that. So those are supposed to be the same lengths. So the distance between these parallel lines is going to be the same, technically. By the way, you know, when someone's drawing, like if you're drawing like some plans to build something, and you're drawing a blueprint, if you're just, a lot of times when it starts off, they don't draw the thing to scale. They just kind of rough draft it. They just kind of roughly draw a picture of it, and they're putting markings on there and measurements and everything like that. And it's not going to be exact because they're just getting a rough idea of what it looks like, right? And then they take it to the drafter, and the drafter will draft it up so everything is to scale and everything's perfect, and now everything looks proportionally right. But you got to remember, sometimes they don't, you know, when they're just doing that rough sketch, they don't do that. And so same thing with math problems. When you're solving a math problem, all the time when I'm solving math problems, I'll draw a picture of the story problem that I'm trying to solve. It's not to scale. In fact, I don't know which side's bigger than the other, so I just draw one. I know the basic shape of it, and then I put the numbers in everywhere, and I solve it. And then I'd go, okay, if I was going to draw this to scale, then this would have to be here, and this would have to be this length, and so forth. But that's what happens. So they do that in mathematics sometimes. I don't know, some math teachers believe that they should draw everything to scale, and some think that we shouldn't. So obviously the people who did this one don't think that we should draw it to scale. So that's their idea behind it. So anyway, that's why it's not to scale. But these are the same. Okay. Are there one or two other questions I can answer? Because this assignment's not due till next time. 6:11. Okay, look at this one, you guys. We've got to solve this triangle. We've only got one side and one angle other than the right angle. So where do you want to start from? Do you want to find a side you want to find one of the sides? You want to find the hypotenuse first? Find the other angle. Well, yeah, the other angle is real easy. What is it? 5 degrees. Now, is this drawn to scale? Definitely not, right? Because 5-degree angle is a lot smaller than that, and 85-degree angle is almost a 90-degree angle. This isn't even close to a 90-degree angle, is it? So this thing's not even close to being drawn to scale. So guess what? If you really stretch this thing out like it should be, okay, then isn't the hypotenuse right here, y, we'll call it y, and that side right there, both almost the same? What's going to be longer? The hypotenuse, right? So does it make sense now? Yeah. So you've got to remember, these things aren't always drawn to scale. So when you get on the test, it might not look like it makes sense by the picture, but you can assume that it is. So, by the way, I just want to show you. So let's call the hypotenuse x. If I have angle B, I have the opposite side and the hypotenuse. Which of the ratios am I going to use? Sine, because it's sine of 85 degrees is equal to opposite side, which is 10 over hypotenuse, right? Just reviewing, when x is in the denominator, how do I go about solving this? I told you guys the fast way is just to switch the x and the sine of 85, right? But let me show you why you can switch them. It's because if you times both sides by x, this gets the x out of the denominator. Because those cancel out over here, and I have x times the sine of 85 degrees equals 10. Then I got to get x by itself. It's being times by sine 85, so what do I do to both sides? Divide by sine of 85. Those cancel out, and I get x equals 10 over the sine of 85. Okay? And I just put that in my calculator, and 10 times the sine of 85 is the same. But notice you could have gotten that just by switching the sine of 85 and x. Okay? And what'd you say it came out to be? 10 point something? Yeah. 10.03? 03 what? 8? Okay. Now, you guys, let me just ask you this. What would be the easiest way to find side CB over here? I'm going to call it y. Well, Pythagorean theorem, except for to use the Pythagorean theorem, I'm going to have to use that number, which is not exact number. It's a rounded number, right? I'd have to use that number. So it's probably not the best way to do it using the Pythagorean theorem. Tan of A. Okay, so the tangent of A, and A is 5 degrees, is equal to opposite side over adjacent side, right? And so I times both sides by 10, and so I get 10 times the tangent of 5 degrees equals y. I actually think this way is faster anyway than using the Pythagorean theorem, isn't it? Yeah. So 10 times the tangent of 5 degrees, and what did you guys get? Huh? 0.87? Does that make sense for what the picture we drew a little bit ago? Yeah, it's not going to be very long, is it? Okay, so that's what it looks like. Okay, what's your other question? 22, and what's your other question? 21? Are those similar problems? Okay. Can I borrow this again, Jacob? 21 and 22. How many of you guys have drawn a picture of those? Can I borrow it for a second? Okay, so let's talk about it then. Number 22. All right, we'll do 22 then. I'll help you draw the picture later if we need to. Okay, 22. Michael is designing a house with a roof pitch of 5. What does that mean? Roof pitch is the number of inches that a roof will rise for every 12 inches of run. So, in other words, what's the slope of this? What's the slope of the roof? Huh? Say that again, Kurt. 5 to 12, yep. It's 5 over 12, or 5 to 12. That's the pitch of the roof, okay? So it says, if they say the pitch of the roof is 5, and it defines roof pitch by saying it is the number of inches that a roof will rise for every 12 inches of run. So that means every 12 inches you go this way, it rises 5 inches this way, right? And it creates that slope right there. By the way, that's a common pitch of a roof in this area. That's what most houses are. Like when you get up into like mountainous areas where it snows a lot, they make them a lot steeper so the snow will slide off them a lot easier. But around here, we don't get a lot of snow, but we get rain, so they make a 5/12 pitch. So it still goes off, but doesn't need to go off as fast. All right, what is the angle that will need to be used in building the trusses and supports for the roof? Which angle do you think they're talking about? I'm guessing they mean this one right here. By the way, they're talking, because you're talking about the angle that creates the rise, the run and the rise right there. I think it's that one down here. What is the angle of the roof with a 5/12? What is the angle of a roof with 5/12 pitch increase? Wait, what is the angle of a roof with 5/12 pitch increase? At the peak of the roof, what angle will there be when the front and back of the roof come together? Okay.
So you first find the full angle, then you get the top angle.
Yeah. Okay, so how do we find this angle down here? Why sine? Yeah, I was going to say it's a tangent. And what do you guys want? Should we call it A? Tangent of A equals 5/12. So we're going to find the tangent inverse of 5/12, right? That's what A is equal to. And what is it? 22.61 degrees. So what would that make this angle up here? What's this one? 67.39? Well, if you got 0.61, it's 3.839. Okay. So, what number was this again? 22. Okay, so that angle at the top is 67. Now, if I put the roof down the other way like this, that's another 67.39 degrees or 3.8 or whatever you guys said, right? So what's the whole angle created? 134.76. That's what it's asking you to do. Okay? Well, yeah, because you're just coming down the roof from the other side, right? So isn't that going to create the same angle? It's the same pitch over here, right? So you just add those two angles together to get the whole angle. Okay. So number 21, you guys, Susan is designing a wheelchair ramp. Wheelchair ramps require a slope that is no more than 1 inch of rise for every 12 inches of ramp length. So that means if you're going to go 12 inches this way, you can go 1 inch up that way, right? Not a very steep slope because you got to get a wheelchair up it with your hands, right? So Susan wants to determine how much horizontal distance a ramp of 6 feet in length will span. Well, if you're talking about a ramp, you're talking about, aren't you? Which is the hypotenuse. So this is 6 feet. Okay? The ramp is 6 feet. Susan wants to determine how much horizontal distance a ramp of 6 feet in length will span. They want to know this horizontal distance given
6 inches high.
Given that 6 feet right there, right?
Right. 12 sections by 12, which would leave it 6 inches high and 2 inches tall.
Well, 6 times 12 is what? 72 inches? So this is 72 inches. Right?
Right.
And you're saying,
The height of it is 6 inches.
why are you saying 6?
Because for every 12 is 1 inch. And so 12 times 6.
Well, remember, this has got to be, you got to use the Pythagorean theorem to get that answer. So you're saying, since there's 6 of those, 12 times 6 is 72 right here.
No.
Well, why are you saying the bottom is 12 and 6? Well, I don't think this has to be, I don't know what this is right here, but let's just look at this. Let's look at the rest of this. So Susan wants to determine how much horizontal distance a ramp of 6 feet in length will span. She wants to know this distance if you have a ramp that's 6 feet or 72 inches, right? She also wants to know the degree of incline from the base of the ramp to the ground. Okay, now we know that there's got to be a 1 to 12 ratio on this, right? So, and she also wants to know this angle down here. Also wants to know the angle of incline right here. So, well, first of all, we could probably find the angle of incline using this picture over here, couldn't we? Can we find this angle right here? How would we use it? What was that? Yeah, tangent inverse of opposite over adjacent, right? Okay, put down your calculator. What do you get? Huh? Give me 3 decimal places. Okay, so
4.763. How tall is it?
So we'll just call it 4.764 degrees, right? That's the angle. Now, could we find the x distance now that we have those 2 things? Because you either need a side and an angle or 2 sides to find something other than a right angle. Right? You can't, you have to have at least 1 side. Okay? It doesn't really matter how tall it is because, well, I mean, it does to us, but all she wants to know is how long that's going to be. She says she wants to know the horizontal distance it's going to span. So what am I going to do to find x? Which side do I want? Adjacent and cosine 4.764 degrees equals x over 72, right? So our answer is going to be 72 times the cosine of 4.764 degrees. What is that? 71 point what? Inches. Does that make sense? If the hypotenuse is 72, does it make sense that that leg would be 71.75 inches? Can we? What were you thinking of writing a proportion? Yes, you can. Good. So you got square root of 145 right here. So Roger's asking, can you use proportions right here? Yeah, it's all related. That's why we're doing it all in the same module. Good idea. So then what did you do from there? Equals? It's 12 over x. Because you wanted to know this side, right? Oh wait, I went to x over 12. Did you do that? Yeah. Well, because you went 72 over 145 equals x over 12. So we should get the same exact answer. 72 times 12. So what's 72 times 12? Let's just do it out real quick. Huh? 864. So x is going to be equal to 864 divided by the square root of 145. should get the same answer. Did you get it? Okay. See, Roger, good job, Roger. Roger found a different way to find this using proportions. Nice job. Okay. Let's read that again, because I might have read it wrong. Where is it? Okay, it says, Susan is designing a wheelchair ramp. Wheelchair ramps require a slope that is no more than 1 inch of rise for every 12 inches of ramp length. Oh, we did do it wrong. I thought it said run.
Actually, but I did it. That's what I did. I got the same answer. So it doesn't matter.
Well, no, you wouldn't get the same answer.
I did. It would have been.
Yeah, because look. So you guys, it's supposed to be this and this.
Yes. That's how I knew it was 6 inches high.
I didn't pay attention to that particular. Okay. So we know that's, and then the problem that we have wants to know 72. Is that what it wanted to know? 72 right there, right?
Yeah. 6 inches high.
So that's why you were saying 6 inches.
Yes.
Okay?
I tried to tell you before.
Because 1 times, I mean, this is 12 times bigger, so 6 times 12 is 72. That's why you were saying that. Good job, Kelvin. So it wants to know the ramp length. So now we could use the Pythagorean theorem, which is going to be 6 squared plus x squared, call this x, equals 72 squared, right? So x squared is equal to 72 squared minus 6 squared. Put 72 squared minus 6 squared in your calculator. And then take the square root of that. What does it give you? What does that give you, Kelvin? When you put the square root, you got to put parentheses around the whole thing. Huh? 71.74? Was it the exact same answer?
74, the other one was 75.
Wow. They're not much different, are they?
That's what I was trying to say. Yeah.
Well, if you take into consideration
Same thing with the angle. Yeah.
Oh, we did have ramp length right here, didn't we? Oh, we just didn't put it over here. That's where we didn't put it. Okay. All right, the second one is a more accurate way.
What does it say?
Okay, we need to move on. Okay, so next time, which is Tuesday, we are having a test on Tuesday. I am going to review for 15 minutes right now, and I'm going to review for about 25 to 30 minutes at the first of class next time. I would suggest that you review on your own. You need to know dilations. That was 6.1 and 6.2. You need to know about similar polygons, similar triangles, and when you write and when you draw a line parallel to a third side, remember this, of a triangle, so that creates similar polygons. But with each of those, you need to be able to write proportions that you can solve for the test, okay? And then you need to know your right triangle trigonometry, the SOHCAHTOA we talked about. So you need to know how to do a dilation. You need to actually be able to perform one. You need to know how to find scale factors, okay, on dilations. You need to know how to find proportions on all these things right here, and then be able to do the right triangle trigonometry. I don't know if you guys noticed, but all of these things are related. Dilations are just making similar figures, right? Similar polygons, similar triangles. You know, you can write proportions with them. And then drawing that third line, remember how x over y equals z over r right here? You can write x over y equals z over r. That's a proportion that you can write on that one. And then this right triangle trigonometry. You should know how to do all that. I think you guys know, for the most part, most of this stuff. I will review some of the stuff right now, and then I'm going to review again on Tuesday, just before we take the test. But we are going to take a test on Tuesday. Got it? Okay, so I'm going to review a few things right now. So does everybody have a whiteboard and a marker? What I want to know is, with these, if I had triangles with these lengths, if I had triangles with these lengths, would they have the exact same angle measurement? Okay, I want you to discuss it at your table. Draw out some pictures if you need to. And draw a picture of triangles with those measurements to be able to answer that question. Okay, one person explain. Why is this answer yes?
I'll explain it.
Go ahead, Kyle.
Well, all of those numbers are pretty much those numbers.
And so what do we know about the two triangles? Yeah. You guys understand that? If this is 5, this is 12 and 13, and all those numbers are just double, 10, 24, and 26, then that creates similar triangles, doesn't it?
Right.
And similar triangles have congruent angles. Okay, do we understand that? Okay, on your test, there will be 5 problems like that. Think you can handle those?
Yeah.
All right.
Is this a long test or?
There are a lot of questions. There are 26 problems on the test. 4 pages long. That's because there's a lot of pictures, guys. Okay. So one of the things you're going to have to do, if I give you a center of dilation, and I give you a shape like this, and I could give you a scale factor, it's 2. Would you be able to do a dilation of this? Okay, using a ruler.
Yeah, heck yeah.
Okay, I want everybody right now to get a ruler really quickly if you want. Draw a picture similar to what I have right here. You guys, with a scale factor 2, you're going to make it twice as big, and it's going to be twice as far away, so just keep that in mind when you're writing it on your board. Because if you get in the wrong place, you'll be off your board for your new one. Try it. Okay, just quickly do it. Make sure you know how to do this, because it will be on the test. Okay, find x. Find x. It's not as simple as it looks, I don't think. They're both right triangles, sorry. They are similar triangles, as a matter of fact. These two triangles are similar triangles. These are similar triangles. Yeah. Use that yellow card for your 3x5 card for next test. That's the idea. That's what the yellow card was for. Sorry. You can bring your own if you'd rather. This one might be a little bit bigger.